Emmy Nerder, the most important mathematician you've never heard of, by Helaine Becker. Meet Emmy Noether, the mathematician who solved the mystery of why some laws of physics, such as the law of gravity, never change. Never heard of her? That's probably because not many people have. It's Noether, not Noether, by the way. Emmy was born into a Jewish family in Erlangen, Germany in 1882, and back in her day, girls were supposed to be pretty, gentle, and quiet, cook and sew, get married and have kids, play the piano if their families were fancy, not be geniuses. But Emmy was considered plain, not interested in cooking, sewing, or other homemaking skills, not interested in getting married or having kids, a lousy piano player, super terrific at puzzles and math, which no one took much notice of because she was a girl. When Emmy was 18 years old, she was supposed to start teaching French at a girls' school. This was considered an acceptable occupation for an unmarried young lady, but Emmy decided she'd rather study mathematics at the university instead. This was not considered an acceptable occupation for a young lady. In those days, women weren't even allowed to attend university. Her proud and doting father, who was a professor at the local university, pulled some strings so that Emmy could sit in on classes. She could go to the lectures, but couldn't take tests or get a degree. Emmy was much smarter than everyone else in her class. The other students knew it and didn't much like it. After all, girls were not supposed to be smarter than boys. See here, not be geniuses. They also didn't like her messy hair, her booming voice, and her habit of talking enthusiastically while she ate. See here, be pretty, gentle, and quiet. But her fellow students did like that she helped them with their homework and that they got to take credit for all her nifty ideas, since she wasn't officially a student. When the university finally changed its "no women students" rule 3 years later, Emmy was allowed to earn her degree. Then, she ran into another problem. Women were not allowed to be professors or teach men anywhere in Germany. Emmy loved math so much, she found a way to teach anyway. She did it for free. That let her keep doing her research she loved and come up with new ways to think about and do math. But just like when she was a student, other mathematicians took credit for her work, or forgot to credit her. They knew they could get away with it. If Emmy spoke up, she could get kicked out of the university, since she wasn't supposed to be there. Meanwhile, another super brilliant, messy haired person had come up with a thrilling idea. Albert Einstein's general theory of relativity describes how time, space, mass, and gravity are all connected, and it was a thing of unparalleled beauty. Almost. You see, the thrilling idea seemed to have a hole in it. Einstein's theory depends on some well known laws of physics that explain the physical world. They are laws because, as far as we know, they can never be changed or broken. For example, when you drop a bowling ball, you can be sure it will fall down, not up. That's because its behavior is ruled by the law of gravity. And when you roll a bowling ball, you know it will move in a nice, predictable line rather than wandering off to do loop de loops all by itself. Its behavior is ruled by the first law of motion, which says objects in motion stay on a predictable path. Einstein's general theory of relativity involves the conservation of energy principle, which says the amount of energy in a system must be conserved, or kept exactly the same, no matter what. For example, a bowling ball can't magically be created out of nothing, and neither can energy, nor can energy be destroyed. It can move from here to there or even change form, but the original amount always exists somewhere. Last but not least, it can't be turned into something else completely. A bowling ball could never become a donkey. But the general theory of relativity appeared to be breaking the principle. When real numbers were used to prove the theory, it looked as if energy was disappearing. That was the hole. Many of the greatest scientists of the day tried to solve the problem. They couldn't. Several of the greatest mathematicians of the day were called in. They were stumped too. In desperation, they called Emmy Nerder. You see, as a Jewish female mathematician, Emmy had always been an outsider, and outsiders often come up with their own ways of doing things. That, it turns out, was one of Emmy's secret superpowers. When most of Emmy's fellow mathematicians developed their ideas, they would start with known equations and formulas. But Emmy's method was to look first for any larger patterns. For example, if Emmy were to study socks, she wouldn't worry about the details, such as what kind of thread was used to sew them. She was more interested in figuring out sockness, or what makes a sock a sock. And it was this outside-in approach that helped Emmy pinpoint the reason for the problem in the general theory of relativity. She discovered that everyone had been looking at an area of space that was simply too small. When she widened the view to show the big picture and a big enough area of space, it became clear that energy was not disappearing. It still existed, but had moved to a place outside of where people expected it to be. Energy had been conserved all along. Super Emmy had sewn up the hole in Einstein's grand theory by proving the part of it that no one else could. Everyone, including Einstein, was impressed and grateful. The general theory of relativity became super famous, and so did Albert Einstein. Emmy, however, did not. She didn't mind, though. She was still doing work she loved. Besides, it led her to all kinds of exciting new ideas. While working on the general theory of relativity, Emmy had noticed intriguing mathematical patterns in the data, patterns that led her to an important discovery. The mathematical laws of symmetry and the physical laws of conservation are connected. This discovery proved that each conservation law is paired with a symmetry law, and that led Emmy to understand why the laws of physics are laws and can't be broken. It also proved that certain kinds of physical events will always occur in exactly the same way. Symmetry, whether they happen now or later, here or there, while standing still or in motion. As obvious as this might seem, no one had ever proven it, and that made it a very big deal. In fact, Noether's theorem, as the discovery is still called today, was as revolutionary and earth-shaking as the general theory of relativity. It completely changed our understanding of the universe. And Emmy wasn't done yet. She went on to figure out new math concepts that would be used by scientists to help them understand atoms and by future mathematicians to develop computer software. So why in the world don't we know much about Emmy Noether as we do about other important scientists? You might have already guessed part of the reason. She worked in a field of study that didn't welcome women, and her male colleagues didn't even think to give her credit when they used her work or included it in their own. The rest has to do with a terrible twist of fate. Things had started to go pretty well for Emmy by the early 1930s. She was finally getting international attention from her achievements, and even though not everyone was happy about it, she was earning a small salary as an assistant professor. But then, in 1933, the Nazis came to power in Germany. They promoted the hatred of and discrimination against certain groups, including Jewish people like Emmy. Life became increasingly difficult, and Emmy lost her hard-won university position. Still, Emmy kept teaching, in her home and in secret. Everyone was welcome as long as they loved math. Emmy's friends were scared for her. The Nazis were arresting Jews and sending them to labor camps. Many were never seen again. How long before the brown shirts appeared at Emmy's door, not for math lessons, but for her. With her life in danger, Emmy had to flee the country. In the United States, many people, including Albert Einstein, worked to help Emmy. They found her a job at a women's college, where she was welcomed with open arms. Now, for the first time in her life, Emmy was surrounded by female colleagues and students. It was to be the beginning of a spectacular new career. Tragically, though, Emmy got very sick and died soon after her arrival. Her ideas, however, live on. Noether's theorem is still fundamental in the study of physics, even though most people who use it have no idea about the woman who invented it, and her later work plays an important role in the field of quantum mechanics, the area of physics that studies the inner workings of atoms, and computer science, a field of study that didn't even exist in her day. So, just who was Emmy Noether? Loud lady, great friend, super brainy, inventor of not one, but two major ideas that changed how we understand the universe, very important thinker.